Hello guys, welcome to my channel AK Tech Services. So in this video we are going to see how to create a CAD model for gear as per gear. And for this Spur gear I'm going to use an equation method to create a invalid profile. So without any delay we'll get into the video. So first I'm going to create a new part file in this Creo screen. I just click rename it as Spur gear and I just click OK. So as per gear file has been created, in this first I'm going to create parameters. So to create the parameters I'm moving to the tools workbench and let's click on the relations where we can have relations in the top as well as the local parameters in the bottom. So in parameters I'm going to add a new parameter here and renaming it as pitch diameter, and it is going to be as a real number, and the value of pitch diameter I'm considering as 20 mm. So the next I'm going to create another new file, sorry, new parameter, which the value parameter name is called as teeth. This parameter teeth is going to define the number of teeth in this program. For this I'm going to have it as an integer. Since it is a number of teeth, it should be on a count. It is not required to be a decimal numbers, so I'm going to change the type as integer. So the number of teeth I'm considering also as 20. The third parameter which I'm going to create here is called as the pressure angle, pressure underscore angle. For the pressure angle also I'm going to have it as a real number, and the value of pressure angle is 20 degree. In invalid spur gear there are two different pressure angles which is standard in all the purpose. The first pressure angle is 14.5 degree and the second pressure angle is 20 degree. So in this model I'm going to use 20 degree pressure angle as a references. So once this is done I just click OK here and come back to the system. Before getting into the sketches, I would like to change the model properties as a unit from inches to millimeter. Just set this and just click OK. So next I'm going to create a profile or a circle which is applicable for the pitch diameter. So to create a circle, click on the sketch command, select the front plane and click on sketch here and move to the sketch view. So here I'm going to draw a circle, and without constraining any dimensions I'm just directly going to get exit of this workbench so that I'm going to have a relations here. So just click OK here. As of now I didn't constrain the dimensions, that I'm going to make it in relations. So going to tools. So before getting into tools I will like to rename the sketch as pitch underscore diameter. So moving to tools and click on the relations. So here I'm going to have a relation like the diameter number is d0, select this, and this d0 is equals to pitch diameter. So for pitch diameter I'm going to directly click on the parameter table, right click on the insert relations. So this parameter has been inserted inside the relations. You can just click on the last icon which is verifying, and it shows relations have been successfully verified. So you can click OK here and click OK here and come to model, regenerate, so that here you can able to see the value of the circle has been modified to the value of pitch diameter. So the next circle or the sketch I'm going to draw in the same front plane is the root diameter. So select this circle, select a circle and draw a root diameter. It's not mandatory to constrain here. Just click OK and rename it as root diameter. The third circle which I'm going to constrain here is the outside diameter, or also called as the tip diameter. So select the circle, select the front plane and make a circle here. No need to constrain as of now since we are going to have a relations, and turn it as tip diameter. So now we are going to give relations for root diameter as well as the tip diameter. So move back to the rules, tools and relations. Here the first one is the root diameter. Select the D1. D1 is equals to pitch diameter divided by pitch diameter minus 2.5 times of module. So before adding this tip diameter or root diameter, first we need to constrain the module. So module is equals to pitch diameter divided by the number of teeth. This is a simple formula which we have in the basics of gear design. So the module of a teeth is always equals to the pitch diameter divided by the number of teeth. So you can just verify here a module parameter has been automatically added with the value of 1. Next we are going to have a root diameter d1 is equals to pitch diameter minus of 2.5 times of module. So this is the value of root diameter. Next we are going to define the tip diameter. So tip diameter d2 is equals to pitch diameter plus 2 times of module value. So just verify this and click OK and regenerate here. So here we can able to see the tip diameter value as 22, the root diameter value as 17.5, and the pitch diameter value as 20. So this is the three profiles which is mandatorily required whenever we are making a design of a gear. So the next thing, the most important part of the video, we are going to have a invalid profile curve using an equation. So for that, I'm going to click on the datum and select the curve types and selecting curve from equation. So the basic references need to create a curve from equation is a coordinate system. So I'm going to select the default coordinate system which is available in the model. The next thing, I'm going to click on the edit command in the equation. So the equation dialog box relations has been opened here, and here some of the default parameters also has been added. So to define the equation, I have taken a resource from an internet which I'm going to paste it directly here. I would like to show this. So this is the relations which is used to create a invalid profile of a Spur gear. I'll just copy this resource and I'll just directly paste it into the relations. But I would like to explain each and everything here. The first thing, I will like to define the PD is equals to pitch underscore diameter, and PA is references to the pressure angle. So these two parameters has been directly defined. Now the first line which is going to define is the radius of the invalid profile is always equals to the half of the pitch diameter into cos of pressure angle. So the pressure angle value is 20. So the cos angle of 20-degree value cos 20 is equals to 0.9397. So the radius of invalid Spur gear profile is equals to the pitch diameter, which is 20 divided by 2 is 10. 10 into 0.9397 is equals to 9.397. So 9.397 is the radius value of the invalid profile curve which we are going to create. Next we are going to define another parameter is called as theta. Theta is always and refers to the angle in degree where it changes from 0 to 90. The next one is we are converting the theta from degrees to radians. To convert an angle from degree to radians, the formula is the degree value into pi by 180. So the theta radians will be converted from theta degree into pi by 180. So the next we are going to define the x coordinate value. For the x coordinate value, the formula is r into cos theta plus r into theta in radians into sine theta. Same way we are going to define the y coordinate. The y coordinate formula is r into sine theta minus r into theta in radians into cos theta. If you need it, you can add it as another coordinate z is equals to 0, and you can just click verify. Okay, there's some error is being found since the r is here, invalid r has been defined. Okay, the reason of the error here is the spelling which I have mentioned in the diameter E has been missing. So please make sure whatever the spelling you have given in the previous relations and the local parameters, the same spelling and the same format needs to be followed everywhere. So I have added the correct spelling here and just click on the verify. So it has got been verified. So all the parameters and the values has been added in the local parameter table as well, and you can just click OK here so that you can able to see as per invalid profile curve has been generated here. You can click OK on this curve, click on the front view, and here you can able to see a curve has been generated. Since the curve length is going very outside, we are going to trim the curve with the help of tip diameter. So I'm selecting the trim command. To trimming curve, I'm selecting the invalid curve, and for the trimming object, I'm selecting the tip diameter. And I'm going to flip the direction, since what are the area has been highlighted in blue color, those areas are going to be removed and the rest of area is going to be alive. So I just flip the direction, so this area will be removed and this area will be available. So just click OK. Now you can able to see the trimmed object of this invalid profile. So let me rename it as trim as invalid profile. The next thing, I'm going to make a mirror for this. So to make a mirror, I need a plane which is in the tilt of 6 degree. So before that, I'm going to create an axis which is going to constrain between right and top, and I'm going to create a plane with the help of top plane to the axis with the deflection of 6 degree. So I would like to rename this plane as a mirror plane, and I'm going to mirror the invalid profile with the help of this plane. So click on the invalid profile curve, select mirror command and select mirror plane here. So the gear profile has been generated. Next thing, we are going to make extrusion for the root diameter. So select the root diameter sketch, click on the extrude and select the value of as you require. I'm going to have a value of 2.5 mm in symmetrical way. So the next thing, we are going to make an extrusion of invalid profile. So once again, click on the extrude, select the front plane, move to the sketch view. Here I'm going to project the curve which I have already created. And to get the curve to be as a closed, I'm going to extend it with the help of normal sketch, with where the sketch and the gear profile to be as in a tangent one. Same way in the opposite direction, as well as I'm going to close the arc from the center radius to this point to this point, as well as the same center radius from this point to this point. So the entire sketch has been closed here. Now I just click OK, and the extrusion of this teeth also to be as 2.5 mm in symmetrical way. So now you can able to see a single teeth of spur gear has been generated exactly as per the curve in this invalid profile. Now I'm going to have a radius in the root diameter to avoid the sharp corners with a value of 0.2. Just click OK here, and now I'm going to make a pattern for this teeth. So I select the teeth, making a pattern and moving it to axis pattern, and I select the center axis. So the number of teeth, as we have mentioned in the parameters, is equals to 20 with an angular event of 360 degree. So just click OK here. Now you can able to see 20 teeth has been generated. Once again, I select the round and click on the pattern. So it will directly take the references pattern which we have done for the gear teeth feature. So just click OK. A radius also has been generated to all over the area. So next we are going to have some aesthetic changes in the middle of the gear to have a strengthen of the gear as well as for the shaft provisions. So for that, I'm moving to extrusion in the front view. So make a circle here with a diameter of 7 mm with a keyhole at the top. The width of the keyhole is considered as 1 and this is considered as 2. Let's let it be as 1.5 would be better. Now I'm going to delete all the unwanted lines. And also I'm going to have another circle where the PCD would be like 14 mm. Make this line as to be as a construction element, and I'm going to have a okay that I will take it in a separate extrusion. Okay, that I will take it in a separate extrusion. I just click OK here and reverse the material direction and automatically remove material will be selected and just click OK. So the next thing, I'm going to have three different curve profiles here to strengthen the gear. So same way, click on extrude, select the surface and move to sketch view. Now I'm going to make a circle in a construction mode with a radius of 7 or the diameter as 14. Turn off the construction mode and I'm going to select a center line and to have two center lines like this. The first center line would be like 20 degree and the second one as 70 degree. So it will have 20 degree offset from this and this will have 20 degree offset from here. So the next thing, I'm going to have a circle, two different circles here, one with the radius of the diameter of 13, another one with the diameter of 15, and I'm going to have a circle which is going to be connected tangentially to the both the lines. Now we're going to delete all the unwanted lines here. Select the delete segment and click, just drag over all the unwanted lines. And I'm going to make it as corner and the profile has been completely verified. So in this way, I just click OK here and revert the material direction. So the material has been removed here. And this profile, I'm going to make it as a pattern in axis pattern way based on the center axis with the three profiles in angular event. So here we have three profiles in angular event to improve the strength of the gear. So this is how our spur gear part has been created using the formula or the equation for this invalid profile. So in the same way, I'm going to show how to make a mechanism for spur gear as well. So for that, I just click on the new command and select the assembly and click OK. So in assembly, before going to the operations, I would like to change the unit from the model properties as millimeter Newton second and set. So next, first we going to get the first gear. Before that, I'm going to have a axis here from right and top in this direction. The second gear which you are going to place is with the offset of 20.5 mm as a center distance, so that I'm going to create a plane in the distance of 20.5 mm and going to have an axis from top and the datum one and an axis line here. So this is the two different axis lines for two different gears where the center distance is considered as 20.5 mm. Next, I'm going to click on the assembly, insertion. I'm selecting the spur gear. I'm going to click on the pin connection. Since the gear is to be rotation, I'm selecting the pin connection, select the axis here and select the first axis. And for the translation, I'm going to select the front plane of the gear to the front plane of the assembly and just click OK. So the pin connection gear system of first spur gear is done. Next, we are going to assemble the second spur gear. So click on the assembly, insertion, select the second spur gear. In the same way, we are going to have a pin connection as from the spur gear axis to the axis which we have created in second one. For the translation, as same as for the previous spur gear, front plane to the front plane we are constraining. I'm moving to the front view and I'm going to make a drag component to make the gear as perfectly fits with the area, right? So now two spur gears has been successfully assembled, but both are not constrained with the gear system. So if one gear has been rotating, the other will not rotate. Let me show you how to make it. So I'm moving to the mechanisms from the application tab, and I'm going to add a servo motor for the first gear with the angular velocity value as 5 degrees per second, and click OK. So now if I try to run the mechanism analysis for the first gear, only the first gear will keep on rotating without no any contacts between the second gear. So in this, I would like to have a connection between the first gear to the second gear, so where the gear system will continuously transmit the power. So that I'll just drag the component once again, keep it in the position, and now I'm going to give a gear connection between the first gear and second gear. So for that, I would like to select the gears. For the first gear, select the motion axis, and the pitch circle diameter is considered as 20 mm for the first gear. Second gear, select the motion axis, and for second gear also pitch circle has been considered as 20 mm, and I click apply and OK. In case if you are making a bigger gear to smaller gear, please make sure you have given the correct pitch circle diameter whenever you are selecting a gear mechanism. So now we can able to see a gear profile has been added in the connections inside the gears here, a gear pair. So now if I run the first gear with the motor speed or the input power, automatically the power is transmitted to the second gear, which is a driven gear, and it makes some applications. So going back to the mechanism analysis, make the end time as 100 and click on run button so you can able to execute the model. So guys, I hope you understand how to create a spur gear of invalid profile in this video, and I hope you like this video as well. And also please mention your comments and queries in the comment box. Definitely I will reply for that, and if you need any special kind of videos, please mention that also in the comment box so that you can expect in the futures. So please share with your mechanical engineering friends who is very much interested in CAD modeling. So thank you guys, thank you for watching the video. We'll see you in the next video. Until then, bye bye from AK Tech Services. Thank you.